sir.
So in the last period, we have studied that if there is a homo or there is hydrolytic cleavage, what happens that if you have C R and X, then both the electrons from this goes on X, and you get X minus, and you get C R R1 R2, and then you have one vacant orbital available. This is vacant orbital. Now what happens? Suppose this R is your CH3, let us say. So here what happens? You have C, and this both are, let us say they are HH. So what happens? You have CH2. Yeah, of course you get a positive charge on this carbon. So you finally have CH2 plus, and then you have C, H, H, and H. Now what happens, my dear students, that you have an orbital here, or let me show you this orbital which is vacant is available over here. Now you have this two electrons in the bond of C and H. They generally are going to be shared with this vacant d orbital. So here what happens, the CH sigma bond electron, CH sigma bond electrons goes to vacant d orbital. That's what we can say. They goes to vacant d orbital. Sorry, vacant p orbital. I am so sorry. We have even seen that there was an sp3 hybridization here, which was tetrahedral shape, that has turned to be sp2, and it becomes triangular planar, or we can say trigonal planar. So ultimately what happens, my dear students, that due to this, you'll get this as a double bond. So CH2 double bond C, this H and this H, and this H, as these two electrons from this bond have been lost, my dear students, we'll have to show this H as H plus. This is what it happens. So now I hope you understand. Is there anything which you cannot understand? You can ask me. बच्चों अगर इसमें कुछ यहाँ तक अगर कुछ समझ में नहीं आया तो प्लीज पूछ लो. ये ये जो बॉन्ड है सिग्मा बॉन्ड, उसके जो इलेक्ट्रॉन थे वो यहाँ पे वैकेंट पाई ऑर्बिटल जो कि एक्स के चले जाने से हाइड्रोलाइटिक क्लेवेज होने से बनी हुई थी, उसमें ये इलेक्ट्रॉन शिफ्ट हो जाते हैं. ये इलेक्ट्रॉन आते जाते रहते हैं और टेम्पररीली ये जो बॉन्ड है सिग्मा बॉन्ड है वो टेम्पररीली टूट जाता है और हमें H प्लस मिलता है. इसमें अगर आपको कुछ समझ में नहीं आया तो प्लीज पूछ लीजिए. इज देयर एनीथिंग व्हिच यू कैन नॉट अंडरस्टैंड? यू कैन आस्क मी. शैल वी मूव फॉरवर्ड? आगे चलें बच्चों?
Yes, sir.
Yes, sir.
Okay, that's great. So now what happens, my dear students, that your CH2 plus that has got, CH3. You are very well aware, dear student, that these hydrogens are known as alpha hydrogen. These are alpha hydrogen. That is what we have explained. So these are the alpha hydrogen. And when you have alpha hydrogen present around the carbocation, now you have carbocation. What happens from this? You will get a structure CH2 double bond C H H, and then you have H plus here. This is the structure number 1. But you can see that from this sigma bond and this sigma bond also have electron, and that may go to the vacant p orbital here. So the next structure you may get would be CH2 double bond C H H and then H plus here. So this is the second structure that you may get, and the third structure you may get is CH2 double bond C H H, and here you get H plus. So this is the third structure. Now this is the cation which is known as the ethyl cation. Please remember, this is what it is known as the ethyl cation. This 1, 2 and 3 are known as the hyperconjugation structures. They are known as the hyperconjugation structures, my dear students. And you will realize that, dear student, that number of hyperconjugation structure, number of hyperconjugation structure is equal to, can you tell me what is equal to? Is equal to number of alpha hydrogens, is equal to nothing but your number of alpha hydrogens. You can see that there were 3 alpha hydrogen, 1, 2 and 3, and you got 1, 2 and 3 structures. So in the carbocation, we can easily say that in the carbocation or for carbocation, we can easily write that number of hyperconjugation structure is equal to number of alpha hydrogens. It's very simple to understand, my dear students, that number of carbocation is equal to number of hyperconjugation structure. Number of hyperconjugation structure is equal to number of alpha hydrogens. It's easy for you to understand. बच्चों अगर अभी भी इसमें कुछ समझ में नहीं आ रहा तो पूछ लीजिए, और shall we move? बता दीजिए प्लीज.
यस सर.
मुकुंद सर, टॉपिक क्या है?
Yes, sir.
Okay, that's wonderful that you understood it. Now let's look at the another kind of carbocation. You can see we have this kind of carbocation where we have CH, then CH3 both the side. See, it's easy for us to understand this. So now can you tell me what is the number of alpha hydrogen here we have? See, this is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen, this is even alpha hydrogen, this is alpha hydrogen, and this is alpha hydrogen. So what is the number of alpha hydrogen, dear students? Is it really difficult question, dear students?
6.
6 alpha hydrogen. So how many structures are we going to get? How many hyperconjugation structures are we going to get?
6.
6. It's quite simple to understand. See this way.
Yes, sir.
See, this is the structure number 1. Then similarly, my dear students, we may have this kind of structure. So 3 structures like moving in this direction. CH3, then you have CH plus, double bond C, and then you have H and H, and here you have H plus. So this is the first structure. This is going to be the second one. Then let's look at the third one. CH3, CH, double bond C. Here we have H, H, and H plus here. This is the third possible structure. Let's look at the fourth one. See H plus, then you have H, H, double bond CH, CH3. So this is fourth one. Then my dear students, you may get the fifth one and sixth one. I hope you understand. बच्चों समझ में आ रहा है?
Yes, sir.
Yes, sir.
So you
Yes,
will get
sir.
6 various structures. Same way, dear students, let's look at the next one. Let's look at the next possibility. Suppose you have this CH3 plus. Then you have CH2, CH3 plus. Then you have CH3 twice plus. And then you have CH3 thrice plus. Can you tell me how many or number of structures or number of alpha hydrogen present into this carbocation? Number of alpha hydrogen. Can you tell me how many number of alpha hydrogen present over here? Okay, this is what we have seen. ये तो हमने करके देखा. Can you tell me what is the number of alpha hydrogen present in this compound? Sorry, in this carbocation? Anyone?
High alpha hydrogen.
See, just look at this.
3.
Very good. See, this is the carbon that is having the positive charge. So how many alpha hydrogen now? This is alpha carbon. So this is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen. Can you tell me how many?
3.
3. So what's about this? If I think of this, see, you have CH, then you have CH3, then you have CH3, and you have got positive charge over here. So how many alpha? Very good. Can you repeat, please? Very good.
6.
Now think of this. See, CH3.
9.
Very good, very good. And here you will have 0 because there is no alpha carbon, so there is no alpha hydrogen. Now there is a rule, my dear students, please understand this, that stability directly proportional to number of hyperconjugation structures. And we know that number of alpha hydrogen is equal to number of hyperconjugation structures. So here you can write number of hyperconjugation structure is equal to 0, 3, 6, and 9. Let me tell you one more interesting thing, my dear student, that this is what it is known as the primary carbocation. This is what it is going to be secondary. This is what it is going to be tertiary. This is what we call it as a methyl carbocation. So according to this, my dear students, we can easily say that we have this much of the structures that can be produced. Now, can you tell me the order of stability? Which one is going to be most stable? Can you tell me the order of stability? So we can write this way, my dear students, that order of stability we can write the order of stability in such a way, my dear students, that methyl carbocation is less stable than ethyl carbocation. Ethyl carbocation is less stable than, or primary carbocation, this is methyl carbocation, secondary carbocation, and secondary carbocation is less stable than our tertiary carbocation. So we can now explain. So the stability order of carbocation, please remember that stability order of carbocation can be explained using hyperconjugation. And that is what I have explained you, or that is what I have told you when I have made you study about the carbocations. So is there anything which you cannot understand? You can ask me, बच्चों. अगर इसमें कुछ समझ में नहीं आया तो आप पूछ सकते हैं. Should we move forward? Okay, dear students. Now we want to study about the free radicals. You know, free radicals are the species, they are produced by the homolytic cleavage. Please remember that free radicals are generally produced by the homolytic cleavage. So whenever we have the homolytic cleavage, my dear students, we know that if we have CR, R1, R2, and then if we have X, or let us say then if we have Y, because we have used X last, the two electrons will go to both the atoms like C and Y, and each atom will get one electron. So here again you can see that there will be such condition where, my dear students, we'll have carbon. This carbon has got this 3R, R1, R2. There is a vacant orbital, p orbital on this carbon, which has only one electron. Please remember that this has got only one electron. And you can even have Y, that is even the free radical. And this is how these free radicals are formed. So due to the homolytic cleavage, we get these free radicals. Again, this is the orbital which is electron deficient. This is the electron deficient orbital. This orbital is still electron deficient. Now let us understand, suppose these two are H and this is CH3. So let us think it this way, that you have this CH3, okay, then you have this C that is having, you know, the free radical. So we'll put a dot on it that has got this one electron present into it, and then you have 2H present into it. So it is ethyl free radical. It is like CH2, CH3 and free radical, which we call it as a ethyl free radical. Now what happens? There is again a homolytic cleavage. There will be again a homolytic cleavage here. And you can see that there are two electrons present over here. So one electron goes on hydrogen, another electron goes on carbon. So what happens here, my dear student, that this carbon and this hydrogen free radical, this is what you have H, this is again you have H. This vacant orbital oxygen, this vacant orbital has got one electron, and one electron from this carbon. They make a pair and they make a double bond over here. This double bond, my dear students, please remember that this double bond is formed by, one electron that is coming from carbon. We will show it this way. And the another electron, one electron that is from carbon free radical, and the another one is from this carbon. That is how you can see very easily. So this is the kind of structures, first structure you are going to get, where this hydrogen turns out to be a free radical and remains away from this structure. So this is the first structure. Same way you can have the another structures, my dear students. Please mind well that you may have this kind of free radical where this hydrogen again undergoes and become free radical. Same way, my dear students, you can see here that again you have this kind of free radical possible. So you can see even here that this is the alpha hydrogen, this is the alpha hydrogen, and this is the alpha hydrogen. And you can easily understand here in this case of free radical also that for free radicals, number of hyperconjugation structure is equal to number of alpha hydrogen. The same thing you can even understand about the free radicals, that the number of hyperconjugation structure is equal to number of alpha hydrogen. बच्चों अगर इसमें कुछ समझ में नहीं आया तो पूछ सकते हैं. Is there anything which you would like to ask? You can ask me. Should we move forward? चले बच्चों आगे.
Yes, sir.
Yes, sir.
Sir.
Okay. Now you think about the various types of free radicals here. This is CH3. Then you may have CH2, CH3. Then you may have CH3 twice, free radical. And then you may have CCH3 thrice free radical. Now we just need to know what is the number of alpha hydrogen present over here. Can you tell me the number of alpha hydrogen? Here, what is the number of alpha hydrogen, my dear students?
0,
0.
Here,
3,
here,
6,
6.
6,
and here.
9.
9,
9,
So can we write now the stability order for them? Stability order for free radicals. Can you tell me what can be the free radical stability order? This is what we call it as a methyl free radical. This is what it is known as the primary free radical. This is what it is known as the secondary free radical. This is what it is known as the tertiary free radical. So what we can write is methyl free radical is less stable than primary free radical. Primary free radical is less stable than secondary free radical. Secondary free radical is less stable than tertiary free radical. Or we can write CH3 free radical is less stable than CH2 CH3 free radical. It is less stable than CH3 twice free radical. It is less stable than CH3 thrice free radical. So I hope now, my dear students, you have understood about the stability of free radicals. If you have any doubt, you can ask. Or let's move forward. Now, my dear students, we want to study about the hyperconjugation. In alkenes. please remember that we want to study about the hyperconjugations into the alkenes. Suppose you have this kind of CH2 double bond CH, and this is CH3, my dear students. Now what happens here? You have this 2 electron of this pi bond. Let us say they go to the CH2. So now this CH2 will have 2 extra electron, and due to that it will get a negative charge. I hope you understand, my dear students. बच्चों क्या आपको ये समझ में आ रहा है?
Yes,
Then you
sir.
have this CH, and due to this movement of electron, the electron from this hydrogen bond, just 1 minute. Here we have 3 CH3. The electron from this bond, they come here. I hope you understand. So due to that, my dear students, we will get a kind of hyperconjugation structure where you have negative charge on CH2, then you have CH, then again you have double bond CH and H, and of course, my dear students, here the hyperconjugative H plus, because all the electrons or both the 2 electrons from this CH sigma bond, this is the sigma bond, make the hyperconjugative structure number 1. Here also, my dear students, you can find out the alpha hydrogen, and this is the alpha hydrogen, this is the alpha hydrogen, this is even the alpha hydrogen. So here you can find out the alpha hydrogen. Same way, my dear students, we can expect this to happen. CH2 double bond CH, and then you have CH3. You can expect this electron to go here, and there will be double bond CH double bond, and again you may have this H, and then you have H plus over here. So this is the way, my dear students, we can even understand the hyperconjugation structures in alkenes. Bachcho, can you understand the hyperconjugation in alkenes? Dear students, are you able to understand the hyperconjugation in alkenes? Do you understand the hyperconjugations in alkenes?
Yes, sir.
Okay, thank you very much. So here also, my dear students, we can say that the number of hyperconjugation structure is equal to the number of alpha hydrogens, and or the more we can say that stability of, or let me use the another slide. We can here even say that number of, or stability of alkene is equal to number of hyperconjugation structures. So please remember, my dear students, that the stability of alkene depends upon the number of hyperconjugation structures. Suppose you have CH2 double bond C, and then you have CH3 and CH3. And then you have CH2 double bond C, H, and then CH3. Where will you find, or which one is more stable? Which one is more stable? Can you tell me? Out of this, which one is more stable? Which one is more stable? 1 or 2? Can you tell me which one is going to be more stable? Number 1 or number 2? Please reply faster.
Number 1, sir.
Can you tell me the reason why number 1 is more stable? Your answer is absolutely correct. Number 1 is more stable. What is the reason? Just try it out, my dear students. You can see that here you have 6 alpha hydrogen. Here you have 3 and here you have 3. Which marks or where the hyperconjugation structures are possible, and here you have only 3. So this is how, my dear students, we can truly understand about the stability of the alkene 7. If you have anything to ask, you can ask me. Okay, my dear students, I'm going to give you one more example. See, my dear students, this is the cyclohexane that is bonded to a carbon, and then you have CH3, and then you have CH3, and there is a positive charge on it. And then you have CH3, CH3, and then you have CH3, and then positive charge on it. Can you tell me which one is going to be more stable, or what is the number of hyperconjugation structure possible? This is the question for you. That is what we need to solve. You just need to tell me which one is going to be more stable. Which carbocation is more stable? 1 or 2? See, to understand this, my dear students, we first need to understand this structure. So, if you look into the cyclohexane, that is your C, then you have CH2, 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 and again you have CH2. Now look at this carbon, the valency 1, 2 are used. There is only one hydrogen present. This is what is bonded to the carbon, which is having the positive charge. And then you have CH3, and then you have CH3. So here you can see that the number of alpha hydrogen, my dear student, is 3 alpha hydrogen here, 3 alpha hydrogen here, and 1 alpha hydrogen here. So total number of alpha hydrogen is equal to 3 plus 3 plus 1, that is going to be 7. But here if you look at, you have 3 alpha hydrogen here, 3 alpha hydrogen here, and 3 alpha hydrogen here. So number of alpha hydrogen is equal to 3 plus 3 plus 3, that is going to be 9. So definitely, my dear students, we can say that number of hyperconjugation structure for 1, we can easily write this, my dear students, that number of hyperconjugation structure is equal to, for 1, my dear students, we will have 7. For 2, my dear students, we will have 9. And that is why 2 is going to be more stable than 1. So we can write it here very clearly that 2 is more stable than 1, my dear students, and that is how we can write it this way. So my dear students, it's quite simple and quite easy for you to understand. Now you can solve any such problem by using the knowledge of the hyperconjugation. Now do you have any doubt? You can ask me, or my dear students, you can, or we can move to the, or you can move to the next class. Okay then, my dear students, I hope you have enjoyed the class, and I wish you happy learning.